discussing are realizing their gains only by leaning out their systems beyond the safe operating limits, I believe, of the engine that would allow the engine to maintain those states for any long period of time. I believe that they are getting those gains at the expense of engine longevity. And I really need to drive that point home. I don't believe that the gains are coming from the actual HHO. When you see an electrolyzer cell with its outlet tube in a glass mason jar going, sorry folks, that's not going to do it. When I inject 2 liters a minute into an 11 horsepower generator engine attached to a 5,500 watt generator, that makes a difference. But that's a very small displacement engine. But that makes a difference that you can hear. You inject 2 liters a minute into an engine like that while it's running and producing power, you'll hear the engine RPMs increase maybe 50, 70, 80%. All right, and you'll also hear the combustion process move out. It just sounds like more of a flywheel. It really, the difference is amazing. But now take that same volume of HHO and instead of applying it to a lawnmower size engine, apply it to an automotive engine or an industrial diesel engine or agricultural equipment or manufacturing equipment or marine equipment. Those engines have vastly larger displacements and they're taking in huge volumes of air. And the tiny, tiny drabs of HHO that are being produced and mixed with that, you cannot possibly realize the benefits from that. What you might realize is the benefits from the steam and the water vapors that are being carried along with it in the process of trying to generate the amount of HHO that you think you generated enough of. So the basic rule of thumb that I have found that seems to hold true is that you need to be generating at least 1 liter per minute, preferably twice that, 1 to 2 liters per minute per liter of engine displacement. Okay, so that means if you have a 5.7 liter V8, you want a 10 liter per minute cell, or at least a cluster of cells capable of producing 10 liters per minute. Now, I'll tell you what, folks, that takes 1 serious alternator, and that means you either need to replace the factory alternator with an extra heavy duty one if you don't have the room, or you need to add a secondary alternator just to power the cell to make that happen. And again, we are not only retrieving back the BTU energy, the caloric energy of HHO gas that we are injecting along with the gasoline in the combustion process, but in the process of doing that, we are also changing the way the gasoline, which is present with it, is burning. And we are causing the engine itself to operate at something higher than 18% efficiency. So if we get the engine to 25 or 27% efficiency, that's a 40% gain. And that's a realistic number. But to get there, think in terms of real numbers for the amount of gas that you need to generate. The 8-inch EBN cell that I have in my car, I don't have an alternator big enough to hit it hard enough to produce the amount of gas that cell is capable of producing. That cell is capable of producing 8 liters a minute if I hit it with 100 amps. Okay, now these are numbers that really blow most people's minds out of the water. But you talk to any kid going down the road with a boom, boom, boom car stereo, and he knows what it takes to make that big boom, boom, and he knows that he needs a heavy duty alternator. He knows he needs that second battery in the trunk. Right behind his amplifier to make those speakers go. And that's what it also takes. You need to be thinking in those terms when you're installing a hydrogen electrolyzer cell. To make that cell go, you need current. And you cannot be afraid to send it current, but you also cannot send it that amount of current over a 22 gauge wire.
I'd like to step in here and reaffirm what Zero said. When you talk about 100 amps, you need 100 amps if you're going to have output.
Right.
And guys like myself who are part of the EV community running electric cars, we think in terms of way beyond 100 amps, we're running like 300, 400, 500, I race at 1,000 amps, so
Easily.
we're pumping a lot of amps, and so we're even thinking in terms of most people, okay, most people drive, when they drive, they only drive no more than 2 hours a day. So you could have a battery pack in your trunk that could power a big system instead of an alternator running off your engine, or a combination thereof, and pump enough amps to be putting out over 10 liters per minute without a problem at all. So down the line, we've got to combine all these technologies and pick the best of all worlds to find out where are we going with this. This is a transition technology, and it's taking us to new limits. This meeting here, this past 4 days, I came in yesterday, and I am amazed at the transition stuff that I've seen. And I know in 6 months' time, when we have the event up in the Mid-Atlantic over at the Jarbo's Mill event, we're gonna see new things brought in, new ideas, new ways that it's been crafted. Each time it's getting better. So that, think in terms of high amperage, and you need to get there with a big alternator or a battery pack if you're only running a couple hours a day.
Larry, how do you advocate, if you're making 10 liters a minute, pumping that into your engine, that's great, you're going 60 miles an hour, what happens when you stop at the stoplight?
It doesn't make that much of a difference. It idles, keeps your idle up a little bit, but not that much. It's amazing how much it takes to jump over.
I can say, sir.
That's the scalar property of hydrogen.
I can say that if you're at an idle for any length of time, there is no real reason to have the hydrogen electrolyzer running at that time, okay? And that's one of the things that the VMU is capable of helping you do, because it has a throttle position sensor input right in it, and it can shut down the electrolyzer for extended idle periods. Not only preventing additional heat buildup in the electrolyzer, but also saving on the wear and tear of the alternator. Yes, sir.
I've just kind of gotten here late, you may have already discussed the matter, but this 100 amps, is this just direct DC current, or is it pulsating in any kind of frequency, or has that been an option that's been talked about, or?
Okay.
You know what I'm saying, as far as
Yeah, that's a good question.
modifying the current, is what I'm saying.
Well, essentially, we're still on the topic of brute force electrolysis, and you can think in terms of DC. But for instance, the brute force electrolyzer that I have in my Honda, I have it running at approximately 30 amps. All right, and that can be 30 amps DC, or it can be 60 amps pulsed at 50% duty cycle, which is still the same total power input going through the cell. And that's what my pulse width modulator design does, because I set my